Now, this section is about inverse functions. Okay, for a function f, its inverse we denote f to the minus 1 of x. I'm not entirely happy about that notation because it looks like a reciprocal of f. It's not. No, it's not. But, well, okay, it's a notation collision that happens in math sometimes. What it is, f inverse undoes what f does. So f inverse of f of x is x, and that's the same as f of f inverse of x. So whatever given x, wherever f sends it, f inverse takes it back. They invert each other. So another way to put it is that y equals f inverse of f, sorry, y equals f inverse of x if and only if f of y equals x. So f and inverse do opposite things. So for example, if f of x is x plus 7, the inverse is x minus 7. F adds 7, f inverse subtracts 7. If g of x is twice x, then the inverse function is x divided by 2. If h of x is x cubed, then h inverse is the cube root of x. Now we'll graph all of these and see something rather interesting. Here's the graph of y equals x plus 7. Here's a graph of y equals x minus 7. These two graphs are symmetrical by flipping through this diagonal where y equals x. Here's a graph of y equals 2x, a line through the origin with slope 2. Here's a graph of y equals x over 2, another line also through the origin with slope 1/2. And again, these two graphs are symmetrical by reflection through the line whose equation is y equals x. Here, this n-shaped curve is a graph of y equals x cubed. This s-shaped curve is a graph of y equals cube root of x. And again, these two curves are symmetrical to each other by flipping through the diagonal line where y equals x. In general, if this is the graph of y equals f of x, then y equals f inverse of x is the graph of x equals f of y by the definition of f inverse. Y equals f of x and x equals f of y and y equals f of x are the same really, except that x and y are flipped. And geometrically that's the same as exchanging x and y axes, or in other words, flipping through the x equals y diagonal. So that's how a graph and its inverse graph look. So f inverse graph is the same as a graph of f, we'll flip through the diagonal. Now to find a formula for f inverse, you write x equals f of y and then solve for y. Basically, f inverse is basically transposition. You generally have to use a lot of transposition. For example, f of x equals 1 plus a cube root of 2x. Find f inverse. Well, y equals f inverse means f of y equals x. Now pulling y into this equation, into this formula, you get 1 plus cube root of 2y, and that's supposed to be x. To solve for y, well, let's first undo this adding 1 by subtracting it from both sides. So cube root of 2y equals x minus 1. Now we undo this cube root by cubing both sides and get that 2y equals the cube of x minus 1. Then we undo this doubling by dividing both sides by 2 and get y equals x minus 1 quantity cubed, all that divided by 2. And that is the inverse function. F inverse of x is x minus 1 all cubed, all divided by 2. Now notice a curious thing happens. Let's look at how f of x is defined, how f inverse of x is defined. To calculate f of x, you start with x, you double it for 2x, you cube root it for cube root of 2x, you add 1, so 1 plus cube root of 2x, and that's f of x. To find f inverse of x, this thing, you start with x, you subtract 1 from it for x minus 1, take it to the third power, x minus 1 cubed, and divide by 2, x minus 1 cubed over 2, like this. But notice, plus 2 divide by 2, cube root cube, 1 plus minus 1. These are inverse operations, but they're in the opposite order. So inverse functions are opposite operations in the opposite order. All right. Sarabia Hernandez, let me make a note. Welcome. Good morning. All right.
Good morning.
Now, the trouble with flipping through a diagonal is that sometimes you don't get the graph of a function. For example, here's the graph of y equals x cubed. If I flip it through the diagonal, we get this graph here, a sideways parabola, but it's not a function graph because it's not one-to-one. I mean, it's this upper half is the graph of a function, y equals square root of x. This lower half is the graph of a function, minus square root of x. So really, this is a graph of two functions. So we do not have a single inverse for this thing. We say that a function is one-to-one if different inputs yield different outputs. A not equal to b means f of a does not equal f of b. So I mean, as we can see here, this is not a one-to-one function, and it doesn't have this is not a one-to-one function, so it does not have a unique inverse. So f of x has a single inverse if and only if it's one-to-one, if and only if it passes what's called the horizontal line test, meaning that every horizontal line passes through the graph at most once. So this graph passes, but this does not because it passes through the graph twice. Okay, so for example, is this function one-to-one? Yes, it is. Every horizontal line matches and meets it once. Is this function one-to-one? Well, clearly not, because here's a horizontal line that meets it twice. Here's another one that meets it twice. So no, it's not a one-to-one function. Now, let's go about inverting functions. Here's a function 2x minus 1. How do we invert it? Well, y equals f inverse of x means f of y equals x. Plugging y into this formula, you get 2y minus 1 equals x. And now to solve for y. First add 1 to both sides, 2y equals x plus 1. Divide by 2 and get y equals x plus 1, all that over 2. And that's the inverse. F inverse of x is x plus 1 all over 2. Now again, opposite operations in opposite order. F takes x, doubles it, and subtract 1. F inverse takes x, add 1, and divides by 2. Now this one, it's a little more complicated. Invert f of x equals x plus 4 over x minus 3. By the way, a function of this sort, ax plus b over cx plus d, is called a linear fractional function. Never mind. Its graph is a hyperbola. Now, okay, to invert that, we start as usual, y equals f inverse of x, therefore f of y equals x, and substitute y plus 4 over y minus 3 equals x. And we're to solve for y. Well, that's annoying because first of all, y is in two places here and also it's being divided. Division is annoying. Let's get rid of it by multiplying both sides by y minus 3. So y plus 4 equals x times y minus 3. Okay, good. We'll simplify this right-hand side by distributing x. So y plus 4 equals x, y minus 3x. Now here's the problem. There's y terms on both sides and non-y terms on both sides. Let's move this xy term to the left by subtracting xy from both sides. Let's move this 4 term to the right by subtracting 4 from both sides. After doing that, we get y minus xy equals negative 3x minus 4. Now here we have two y's, but they can be distributed out. You get y times 1 minus x. That equals negative 3x minus 4. Now we can isolate y by dividing by 1 minus x, both sides, and get y equals negative 3x minus 4 over 1 minus x. And that's the inverse function. F inverse of x equals negative 3x minus 4 over 1 minus x. Here's another function. The fifth root of x minus 7 inverted. We'll start the usual way. Y equals f inverse of x. Therefore, f of y equals x. Therefore, substituting, get fifth root of y minus 7 equals x. Okay, to solve for y, let's first get rid of the fifth root by taking a fifth power of both sides. To get y minus 7 equals x to the fifth. Here we'll get rid of the 7 by adding 7 to both sides. Get y equals x to the fifth plus 7. And you're done. F inverse of x equals x to the fifth plus 7. And that's the inverse function to this. And again, opposite operations in opposite order. This f starts with x, subtracts 7, and takes the fifth root. This f inverse starts with x, takes the fifth power, and adds 7. Okay, here we have another linear fractional function to invert. F of x equals x plus 1 over x minus 3. Let's invert it. So y equals f inverse of x means f of y equals x means y plus 1 over y minus 3 equals x from this formula. Okay, now we get to do as before. First, we transpose y minus 3. Y plus 1 equals x times y minus 3. Then we distribute x. Y plus 1 equals xy minus 3x. We move the xy term to the left and the 1 to the right by appropriate subtractions. We get y minus xy equals minus 3x minus 1. These two y appearances of y can be turned to 1 by factoring it out. So y times 1 minus x equals negative 3x minus 1. The division gets you y equals negative 3x minus 1 over 1 minus x, and that is the inverse function. F inverse of x equals negative 3x minus 1 over 1 minus x. Here is a formula to convert Fahrenheit to Celsius. Degree is Fahrenheit to degree is Celsius. Degree is Celsius is 5/9 of F minus 32. So, what's the Celsius degree when F is 59, a little bit below room temperature? What's Celsius degree when F is -4 below freezing? And finally, find F in terms of C. This gives you C in terms of F. Let's invert that. Okay, for the first two, F of 59 equals 59. Well, okay, C at 59 is 5/9 of 15 minus 32. After a bit of arithmetic, that's 15 degrees Celsius. So little cool means 15 Celsius. F equals -4 means C at that value is 5/9 of -4 minus 32. And a bit of arithmetic later, that's -20. So this rather chilly below freezing temperature is 20 degrees below 0 Celsius, which makes sense, and as at 0 degrees Celsius is the freezing point. And finally, to invert this, if C equals 5/9 of F minus 32, well, let's first multiply both sides by 9/5. 9/5 C equals F minus 32. Then add 32 to both sides and get the F equals 9/5 C plus 32. That's the Celsius to Fahrenheit formula. Do we have a graph of a function? Graph its inverse? Well, we flip it through this diagonal line and get this. I've seen people flip it left to right. That's no good. Or up to bottom. That's no good. You got to flip it through the diagonal for the to get the graph of the inverse function. Okay, let's see now. That concludes that.